Hi, and today we are going to study about a brief introduction about what sick building syndrome, that is SBS, mean, what's the history, how did it evolve, and why it is most important for us to identify and rectify this and try to avoid this when we are designing something in terms of sustainability and we are focusing on the health and based on psychological or physiological effects on the occupants that they are living. So keeping this video very short, and please forgive me for the background noises because this is the very less time that I get to record. Please avoid focusing on the background noises, so sorry for that. Okay, so let's come back to the topic, that is sick building syndrome. So what exactly this SBS means? It is a situation where an occupant of a building starts to experience certain health related discomfort or issues which will be linked the amount of the time that he's spending in a building. So there is no specific illness that is can be identified at this kind of a syndrome is appearing, but eventually we can identify based on runny nose or chest conduction and so many other things. If this prolongs, even if the person is not in the particular building, we say that it is building related illness or something based on that. So these symptoms they disappear sometimes when the particular occupant or the individual leaves for the building, but this can be associated in the work environment, in your offices, classrooms, in home, when there is no proper ventilation and there is no proper hygiene present in the particular resident. So this is somewhat a basic idea about SBS. Now the sources, this image is from internet, and I like this image because it has lot of information that you can understand what are the sources of indoor pollutants. Why am I talking about indoor pollutants? Because these are the one of the reasons, primary reasons that affect a human being when he or she is living in the home. So outdoor pollutants can be the foul smells, molds in the home, that is indoor, chemical products like VOC products, cigarette smoking, chemicals. You can use room fresheners, sometimes animal hairs, carbon monoxide, and the gas stoves, burning fireplaces, modern building furnishing materials. All the chemicals surrounding are one of the source of pollutants. There's something also called as bioaerosols. These also contribute to health related illness. So when these pollutants are revolving in the home or circulating in the home, when a person is completely exposed to it on a regular basis, this kind of syndrome generally emerges for a person. So the primary causes of those sick buildings are what? So basically, if you can see that there is inadequate ventilation which holds 50%. That means around 50% solution that can be given to this is if we are having a proper ventilation, that is HVAC. After that, we are having something called as inside contaminants, which I am also saying it as bioaerosol. uh, just like your aerosol particles getting connected, if a person is not well, the flu tries to contaminate, and they usually say if a person is having a cold in home, then eventually everyone has it because the presence of this aerosol present in the air. So inadequate ventilations, inside contamination, outside contamination, building fabric contaminations, your carpets, molds, humidity, cigarette smoking, all these things are one of the primary sources for sick building syndrome. Now, how does this term come and what is the origin, if you want to know? So, this was coined in 1970. It started when the oil crisis in 1973 started. The energy conservation efforts led to the buildings to be more sealed more tightly to conserve the heating and cooling energy. This resulted in reduction in the fresh air entering into the building. So at that time, they recognized this word as sick building syndrome, that SBS, was recognized in 1970 when more airtight or energy efficient building became more common. This officiated by World Health Organization after reporting this phenomena, and this drew a lot of attention because it started having effects on health in a major level. So what were the factors that made it more significant and more serious when we are designing these things, and why ventilation became very much important is because of this scenario. So what were the factors? The factors were first of all, there was a poor indoor air quality, because once when you start to airtight or try to close the windows and everything, so at that particular time there is an inadequate ventilation allowing pollutants to accumulate. Based on it, there are certain cleaning products, furnishing, paints, okay, building emissions itself have chemical contaminants, followed by the molds, fungus due to the wet moisture of the wall, dust mites, and other allergens that can also result in biological contaminants, which I can specify it as bioaerosols. Now, there are certain physical factors also: noise, temperature fluctuation, inadequate lighting, psychological factors such as stress, dissatisfaction with indoor environment. All this started to, contribute to the sick building syndrome. When we understand that, I really like this one image in the net. It really covers all the gesture of it. This is it. So they said that over here you can see 1 out of 4 buildings in US are actually classified as sick. So the building is not feeling well. So how do you understand the building is not feeling well? Because there is no inadequate there is an inadequate ventilation. So around 64 million workers. This post was in LinkedIn, which made me to understand this is a very serious effect in US, but also in many of the countries where we are not reporting it. So there are reporting, but it is not into a huge talk that many people are talking about it and trying to find solutions for it. But we are having certifications based on it. But still, we are not neglecting this parameter most of the time. But day is not far that these things become very serious, and every design concepts will be talking about all sick building syndromes, building related illness, and so on. So you can see this image over here. It says that around 64 million workers frequently experience two or more symptoms which is associated by SBS, that is nose irritation, eye irritation, and headache. Most of you would have faced when you go to a airtight room, or when you have gone outside your home for certain days, and then you come back home and you just start opening the doors and windows. You find a smell, you find some overwhelming, presence in the room. So at that time, this is all related to the sick building syndrome. So 20 percentage of illness are either caused by this aggravated polluted indoor air. So in since 1990, the indoor air pollution ranks as one of the top 5 environmental risks to public health. So this has reached to a stage where we have to start thinking about it. So why indoor air quality? Because temperature, humidity, ventilation, all these things work in one medium, and that is air. And it states that around a world a death occurs every 20 seconds due to poor in air quality, and 2 out of 3 indoor air quality problems involve inefficient HVAC and air conducting system. So this itself gives us an idea that where are we standing in. And this is just how the percentage of people are suffering. 1 out of 6 people are suffering from allergies because of direct relationship to fungi, bacteria in the air conduct system. It's just a US stats, but when we compare to our country, it may be different and more. And another image, you can see that there is some a woman carrying a baby. She's distressed, she's confused. There's the window is closed, ceiling is having a problem, ceiling is emitting some kind of fumes, then kettle, stove, and everything. So every side, there is no proper ventilation, and she's at the stage, being a mother itself, it will be more stressing at that particular time. Having all these things in addition, it makes her more vulnerable. So that's why air and natural daylighting is very much important. When we are designing these factors, we have to make sure that we provide good wall to window ratios and lighting, so that we avoid all these kind of things. So to be more general, what are the effects on human health? So effects on human health are as you would have known, it is respiratory issues, throat irritation, coughing, wheezing, neurological symptoms like headaches, dizziness, difficulty in concentration such as brain fog, dermatological reactions such as skin rashes, irritations, general discomfort, nausea, fatigue, confusion. And if you are exposed to this kind of an environment for a long term, then it has a chronic health disease, asthma, sometimes cardiac arrest, and so on. So these are there. So how can we manage and prevent this? This becomes an important aspects. So for that, we are having something called as standards. For now, let us understand. Generally, we require to have a proper ventilation, adequate fresh air circulation within the building, identifying pollutants, what are the different types of indoor pollutants, and try to address them. We can have use low VOC elements on the buildings, remove pollutants based on having indoor plants, so that it maintains the indoor climate, indoor environment more presentful and calm. Okay. Next, regular maintenance of HVAC. You're having your air conditions. Air conditions also tend to, uh, absorb lot of bioaerosols or contaminants. Even maintaining that also is very much important. Sometimes filters have to be replaced. Control of humidity level, we should keep the humidity between 40 to 60. If humidity is more, microbial activities are more. If microbial activities are more comfortable, there is a growth of bacteria or fungus or something. So then being in that particular environment, you have fungal infection, bacterial infection, and so on. Sometimes use of non toxic materials like low emission materials, furnishing renovations. And we should raise awareness for maintaining healthy indoor practices, uh, incorporate open green spaces, use green walls, healing gardens, something based on that, in order to prevent all this kind of effects. So what are the factors that can access this? The factors are poor ventilation, chemical contaminants, biological contaminants, physiological factors, and psychological factors. So factors that can contribute is if we are not providing a proper sufficient air supply, and it is leading to build up and indoor pollutants. That time it will harbor many molds, bacteria, and dust. Volatile organic compounds, that is VOC, emits a lot of chemicals in terms from the paints, adhesive, carpets, furniture, office equipments, printers, and cleaning products, formaldehyde that has been present in wood, textiles, use of tobacco, all these things, vehicle exhaust, all these things are something called as chemical contaminants. Biological contaminants are nothing but bioaerosols which are having the presence of mold, bacteria, dust mites, pollens. These are all thriving to who are very who become these are the contaminants which become more comfortable in those environment, and they start to multiply because of the poor maintenance of HVAC systems. And physical factors are nothing but poor lighting systems, especially when we are using fluorescent lighting, excessive noise, uncomfortable temperature or humid level. These are all contributing to SBS. Sometimes electrostatic charges from electronic equipments also can add a discomfort. So what are the outcome? Stress, poor workspace design, dissatisfaction with one's working environment, always exaggerating. So all these things help in that. So a quick recap, what exactly SBS works on. Physical symptoms such as headache, dizziness, nausea, eye, nose, throat irritations, it is dryness or itchy, fatigue, coughing, sneezing, difficulty in breathing, skin rashes. And in terms of psychological symptoms, difficulty in concentrating, mood disturbance, and mostly it causes irritability and anxiety. So how do we solve this in more technical aspect, and when we are knowing something, some standards like GRIHA or some kind of standards based on BIS? So what are those? Let us find out. So first of all, we can improve the ventilation, use of low emission materials, maintain clean HVAC systems, control the humidity temperature from 30 to 60%, then increase natural lighting, and create wellness programs and monitor air quality. So also The standards are to provide the guidelines to have a proper indoor air quality, ventilation, environmental health in various types of building and resources. So first one is National Building Code, that is in 2006. So what do they say? They say that they are having a complete guidelines, design, construction based on building across India, including homes, offices, classroom, and they have clear recommendation for ensuring the health and safety and welfare for proper management of indoor air quality and ventilation. Part A, Section 1 of Building Services, Lighting and Ventilation. So this session provides the natural and mechanical lighting in buildings to ensure there is an adequate supply of air. So minimum ventilation rate for offices, there should be around 3 to 5 air changes per hour. Then classrooms, it should be having a ventilation rate of 5 to 10 liters per per second per person as per NBC to maintain a healthy indoor air quality. Homes, NBC emphasizes natural ventilation through windows and cross ventilation to prevent air stagnation. Openable window area should be at least 10% of the floor area. Now, based on this part, part 8, section 3 says that there should be proper HVAC system to control the temperature and humidity with a crucial in preventing, which is very crucial to prevent SBS. They suggest that there should be a design that has an equal exposure to supply of fresh air, which will help to remove contaminants and control humidity, that is around 30 to 60%, to avoid mold or mildew growth. And air filters in mechanical ventilation system should also meet certain standards to capture these pollutants. NBC guidelines on lighting. So based on NBC, we have to provide certain lightings for indoor lighting, both natural and artificial lighting, as poor lighting can contribute to SBS. So offices and classrooms should make use of the design having more natural light and artificial light, like the fusion of artificial and natural light. And mostly we can see that daylight factor, should be used more, around 75% should be completely used in the morning hours by only in the natural light, so it avoids a bright environment, and you can use windows, glazed areas in order to have a good lighting system. Next is based on bureaus of Indian standards. So there are also several sections such as 3362 21 1997. This code of practice of natural ventilation, they also provide certain ventilation guidelines for natural ventilation, how to incorporate, design and promote cross ventilation. Also there are required for basic human body requirements, the temperature and humidity levels that has to be used, and how to design this air conditioning and venting system. And performance of this ventilation system is also by one of the standards which help us to focus on ventilation system in public buildings, including schools, offices and commercial spaces. And it also provides requirements of airflows rate. And also BIS of 1944 code of practice of lighting of public health, public buildings also ensure that we reduce the eye strains and discomfort in the classrooms and offices. So this is about Bureau of Indian Standard. Another one is Energy Conservation Building Code, ECB-C. Here also they focus on how to improve the energy efficiency of a building, and HVAC can be used efficiently to have proper ventilation in air quality and insulation to ensure thermal comfort and reduce the reliance on air conditioning and preventing stale and recirculated air. Followed by we are having another one is Central Pollution Control Board, that is CPCB guidelines. This also under the Ministry of Environment and Forest Climate Change has set an ambient air quality standards and indoor air quality monitoring recommendations. So all the public buildings like offices and classrooms suggest at least have controlling particulate matters, that is PM 10 and PM 2.5 and VOCs to improve the indoor air quality. Also CB also recommends installation of air quality monitoring system in public spaces to track the pollutants such as your carbon dioxide, carbon monoxide and nitrous oxide. So overall, what do we understand? We understand that this syndrome can be eliminated and can our future designs also should take complete understanding of this standards, so that we avoid sick building syndrome and building related illness, and have a good health environment as well as sustainability in a particular design structure in when we are moving forward for sustainability. So this is all about sick building syndrome. Thank you.